Good morning and welcome to Regis University. It's a delight to see you all here for this event. My name is Kari Kloos. I am an Assistant Vice President for the Office of Mission, soon to be Interim Vice President. We are the group that coordinates with Pope Francis's call for Catholic universities to engage environment, sustainability, in what's called the Laudato Si platform, right? You might know that Pope Francis has, in writing, kind of written about the environment, written about the climate crisis, and he has invited people, all people of goodwill, to enter into dialogue, into education, and into action, right, around what's happening in our world. So it's a delight to host the Citizens Climate Lobby for this important event. Honoring climate science education, a tribute to Mike Nelson, who is receiving the Climate Coverage Champion Award. Just to explain a little bit about this Laudato Si platform that the university is a part of, it has 7 pillars. The first is Cry of the Earth, so listening to what's going on in the earth, like paying attention to climate crisis. Connecting that with Cry of the Poor, right? How is it that people who are often the most marginalized economically around the world as well as in our communities bear the brunt, right, of this climate crisis? Adopting sustainable lifestyles. How can we as a community kind of adopt a more sustainable lifestyle? We love ecological education, right, for which we have this award. It's certainly part of our curriculum here as well. We have a required course for students to learn about environment and environmental justice. Ecological economics are part of this platform, as well as ecological spirituality. And finally, we talk about community empowerment and community participation. So to have an event helped here by Junior Reyna in the back around community engagement. Regis's own Tom Jenkins, who's a dedicated member of the Citizen Climate Lobby. Linda Way Farrell Harris, I'm not sure if she's in the room at the moment. She is our kind of sustainability leader in the university, does a lot of work with our physical plant around energy, water, right, important things around sustainability, as well as education and cooperating with students. All of these people help make this event possible today. So thank you so much. And thanks to Carl Straka for our technology expertise in making everything run effortlessly, so it seems up here. I'd like to welcome Luke Clark, who you all know, from Citizens Climate Lobby, to introduce our honored guest this evening.
Good morning, and thank you for coming today. I'm glad you've taken the time to join us. My name is Luke Clark. I am with Citizen Climate Lobby's Golden Jefferson County chapter. It's one of 13 in our state. I'm pleased to see some volunteers from other chapters and have the chance to greet you in person this morning instead of through a Zoom screen as we usually meet. We are here to make our first Climate Coverage Champion Award, and I will tell you in a minute why I think we have no better choice for this honor than Mike Nelson, who is truly a distinguished meteorologist. But first, some background is in order. I actually represent 2 organizations this morning, Citizens Climate Lobby and Citizens Climate Education. The names describe their different and dovetailed missions. At Citizens Climate Lobby, we like to say our solution to climate change is democracy. We work with elected officials, primarily members of Congress, to advocate for policies that will reduce and eventually eliminate the air pollution that is driving the erratic and destructive weather patterns that make our world harder to live in. We are nonpartisan. We have good relationships with members of both major political parties. Citizens Climate Education, as the name suggests, brings together the best current climate science and the solutions that we have at hand. That information supports our advocacy. So I find it fitting that we gather at an institution of higher learning to honor someone for his work educating the public. on science and how we can respond to the enormous challenge that confronts us. Regis is not only an institution of higher education, but it is a Jesuit school. For those of you who may not know, the Jesuit order has for centuries made its mission to provide excellence in education. But it goes farther than that. Because I was blessed with a Jesuit high school education, I was taught that the higher purpose of my studies was to prepare for work in the service of others. And I think that informing the public about the need to take better care of our common home, as Mike has done, goes directly toward that sacred mission. It is indeed work in the service of others. Please join me in thanking Mike Nelson. I think we're ready to start.
Drying out.
I'll keep this here for you.
Okay. Luke, thank you so much, and thank you all for being here today. Thanks to Regis, and by the way, Shauna, would you raise your hand real quick? These are the two you guys need to connect and talk about that for next year. So if Kari and Shauna can chat a little bit, that'd be great for the Colorado Environmental Film Festival. I'm very honored to receive this award, a beautiful award, and I'm still hopeful. I think we can still fix a lot of the problems that we face. We're burning a lot of daylight. We need to get going a lot faster. We've known these issues for 40 years. But I'm going to show you something today that I think could actually get done during this current administration. And I want you to know about it and help spread the word about this, because I will be talking about it quite a bit. Before I do that, and everybody say hello to Mr. Chris Bianchi, who just walked in the room. Chris is the morning meteorologist over at 9 News and is a very good friend of mine, and I'm so happy you're here, Chris. Thank you for that. He's doing a great job over there. Leave it to the younger people to do the TV weather now. I'm going to run a little quick retrospective of my television career. This was shown on the last night of my broadcasting career back in December, and it's about a 5-minute long thing. It'll kind of give you a little bit of my background and the things that I've done. After that, I want to do a presentation about climate change, science, and solutions. I'm so delighted to be honored by the Citizens Climate Lobby, because our little book on climate change, of which there are copies here today that we can have a little signing session afterward, proceeds from those go to the Citizens Climate Lobby. I've never made a dime on this book. I've had, thank you. People have said, there you go, taking that climate crisis and you're to get it to sell your books. It's like, no, the book, you can get an electronic version for free, okay? And today we're going to charge $5 per copy, but the proceeds that go to Citizens Climate Lobby after we just take care of the minor publishing expenses. And I was talking to one of the co-authors, Michael Banks, and he said, yeah, we just sent 40 copies down to a Louisiana CCL chapter because they needed some resources. And our goal in writing the world's littlest book on climate change was to, there's plenty of books like by Michael Mann that are that thick that unfortunately most people won't read. I think they're fabulous. Our goal was to make one that's 10 facts in 10 minutes so that people can get the basics on it. And it's done quite well. It's all over the country. The Audubon Society has used it. Chautauqua has used it, and we'll continue to spread the word. And on the back of the book is a little QR code. And so if you happen to be on the bus or on an airplane and you're reading the book and somebody says, what's that? You can just say, well, just use that QR code and you can download a free version of it. So we'll try and spread the word that way. The co-author, along with Michael Banks, is Peter Tons of NOAA. And Dr. Tons is a brilliant climate scientist. He ran the lab on Mauna Loa for many years, measuring carbon dioxide. Dr. Tons is so smart that if we said, Peter, explain to the average person the science of climate change, he would think he's dumbing it down, and he'd still be 50 floors above them. So my job was to do the storytelling to make it easy to understand. One of the things, as Chris Bianchi knows, that As a broadcast meteorologist, we are invited into people's homes every single day to explain something complex, the weather, and do it in easy to understand terms in about 2-3 minutes. So why any broadcast meteorologist would feel like, I can't possibly tackle climate change in my weather report. Yes, you can. You don't have to beat them over the head with it every single day, but you can relate it to the increase in CO2 in our atmosphere. Why are the storms wetter? Why are the hurricanes increasing in intensity faster? Why is our heat wave hotter? It's all related to a warming world. And as broadcast meteorologists, or as we call ourselves, station scientists, our news directors come to us every day and say, there's a meteor shower, there's an earthquake, there's a tsunami. Can you talk about that? Well, none of that is weather forecasting, but it's all earth sciences. So why would we possibly shy away from the greatest challenge that we face, which is climate change? And everything that people say they're worried about, immigration, the border, the economy, global conflict, it's all related to climate change. So when pollsters say, well, look, climate change is way down there on the bottom, it's like number 8. It's like, because you're asking the wrong question. Any of those things that we're worried about are all exacerbated by climate change. So with that said, thank you so much for this fabulous award. I'm very honored. And I'm going to run a little video from my last broadcast, and then we'll go in and talk about the science and the solutions to the problems that we face. So, are we ready up there, Carl? Carl's giving me a thumbs up. Okay. Oh, by the way, this is all my contact information. I even have a website now. My son-in-law helped me put that together, so you'll find out all the different things I'm doing at nelsonwx.com. And I'm busy in retirement. I have more stuff going on right now than when I was down at the TV station. So let's open the curtain and run the show.
Well, as we've told you, this is Mike Nelson's final show, and after a week of beautiful tributes, this will be the final one.
So a couple weeks ago, Mike and I sat down at Studio B, that's just right next door, to talk about his remarkable career. So I've known Mike a long time, but sitting down with him in a formal interview, it really hit me. This guy's a legend.
A storm can change history, and a severe thunderstorm in southern Wisconsin in 1964 certainly did.
I remember when I was 6 or 7 years old, we had this big thunderstorm come through my hometown of Madison, Wisconsin. Tornado watches, warnings, flash flooding, trees down. Most people would have all freaked out. I thought it was great.
For Mike Nelson, that storm blew in a lifelong love affair with the weather. The awe, the wonder, the science behind it. He still has the first weather station he built when he was 10.
I have the old thermometer in there. I made this out of just scrap wood. Each day I'd write down the pressure and the weather and if it snowed or not.
When you're a kid who loves weather like that, the local TV weather forecaster becomes like a superhero. And for young Mike growing up in Madison, Wisconsin, that superhero was Terry Kelly, the chief meteorologist for ABC affiliate WKOW-TV. Mike watched him every night and dreamed of forecasting the weather on TV himself one day. He even made his own weather map.
I would take it out of the newspaper where the fronts were, and I'd put the lows and highs on there, and then in front of a mirror I'd practice doing the weather.
Fast forward to a teenage Mike Nelson, still dreaming of working in TV news, but paying the bills working at Baskin-Robbins, when the Terry Kelly walks in and becomes a regular customer.
He came into my ice cream store. For me, this is like a football star.
After a year or so of serving his idol ice cream, Mike worked up the nerve to ask Mr. Kelly if he could work for him at the TV station. Answer phones, empty trash, anything. Kelly said yes.
That next Friday, November 4th, 1976, I got hired at minimum wage to work at the TV station, and Cindy and I went on our first date.
That's a good day.
Yeah.
Cindy is his now wife of 43 years. In the 1970s, your local TV weatherman, and they were almost exclusively men, still used magnets and markers to make weather maps. Mike's mentor, Terry Kelly, helped develop the first computer that created weather graphics for television. And still working for Kelly, Mike spent 1979 through 1984 installing these new computer systems at TV stations across the country and training weather teams to use them.
I actually trained Al Roker on the first weather computer he ever had.
That job also brought Mike to Denver in the early 80s to train legendary Colorado forecasters Stormy Rotman and Bill Custer on the first weather computer in Denver. Mike eventually pivoted to become a full-time on-air meteorologist working in Madison and then St. Louis. He arrived in Denver in 1991 for a job at KUSA, then finally made his way to KMGH Denver 7 in 2004. And the rest, as they say, is history.
Nice evening out there with clear skies.
Mike considers education to be a big part of his job, educating about weather, science, climate change. And if you grew up in the Denver metro area and are of a certain age, chances are pretty good that Mike spoke to your elementary school. He probably juggled hailstones, showed how weather balloons work, and most definitely performed his signature showstopper, the tornado dance.
I act out the two different air masses getting into the big fight. This is the cool air, we're in the shades, and then the hot air, of course, is kind of floating around like this, and they get into this big shoving match, and the big thunderstorms build, and the jet stream comes in, and the whole thing starts spinning big and slow, and then smaller and faster and faster and smaller, and that's how the tornado forms. I've worked hard and done a lot of school talks. I think I've talked to 1 million children.
Some of his other resume highlights include winning 20 Emmy Awards and being inducted into the Denver Press Club Hall of Fame. His proudest professional achievement?
Probably becoming a fellow of the American Meteorological Society, because there's only about 30 broadcasters. Yeah, that's the little thing right there. Right there. There's only about 30 broadcasters that have ever been named fellow in the AMS, and it's only 1% of the society is ever elevated to fellow.
That may be the award he's most proud of, but if you know Mike, you know nothing in his work life is more important than the viewers.
I think the thing that I really have always been flattered about and don't take lightly is the fact that despite all the changes in this industry, and there have been a lot of them and it continues to go on, it still boils down to people watch people. And we are invited into people's homes every single night.
So, after 48 years of being invited into people's homes and now phones, 48 years of getting you ready for that next blizzard, 48 years of tornado dances, what's next? Mike says he and Cindy will stay in Denver for now, and that he will still be watching storms, only now from the comfort of his home.
I will keep doing all the forecasting for myself and watching and waiting for the next round of big thunderstorms or heavy snow, because I so enjoy watching our weather.
What do you think the 6-year-old Mike Nelson would have thought if he would have seen the successes you have had and where you ended up in this business?
Pretty good for a freckled-faced, red-headed kid.
A storm can change history, and lucky for all of us, there was a severe thunderstorm in southern Wisconsin in 1964.
When you can figure out at the age of 6 what you want to be and still like doing it 60 years later, that's pretty cool. So that was my last little gasp on TV there. Hang on here. Save this one. Cindy is here, by the way. Wave there. Love you, my dear. We've been together for 48 years, and she's seen every bit of the changes that have happened. And a quick story on Stormy Rotman. How many people here are long enough Denver folks that you remember Stormy and Bill? Great people over at Channel 9. In 1982, Terry Kelly was trying to get this fledgling weather computer business going. And it was so new back then that might be the first computer that a television station had. And everybody in the building would come down to the weather office or the studio to see it, because computers were like mainframes at universities. So we had a system that initially was built on an Apple II home computer, and very crude, as you saw some of those graphics, but being a computer, that was cutting edge, and TV stations would think, well, this would be a competitive advantage by having a weather computer. So it was new enough at the time that when you try and make a sale, they would inevitably say, a general manager, say in California or New York, would say, well, who's bought it? Because they needed to have that credibility that this was actually something that could work. And so Terry Kelly came to me. Cindy and I had only been married a year. And he said, Mike, I have a great announcement. We just sold a weather computer to Channel 9 in Denver, and you're going to be training Stormy Rotman. Now, at the time, 9 News had a 50 share at 10 o'clock. That meant that 50% of all the people watching TV were watching 9 News. It was Ed Sardella and Mike Landis and Mike Nolan and Stormy. And that was the highest rated TV station in the nation. So that's huge credibility, because if you can say, well, 9 News in Denver likes it, they'd be like, wow, that's the highest rated station in the country. And then you say, well, Stormy Rotman thinks it's great. Well, Stormy was like AMS SEAL number 2. I mean, he was a legend all across the nation back then. So Terry said, Mike, I want you to go do the installation. And he said, you can take Cindy along, because I know you love the mountains, stay an extra day or two. And then he said one more thing. He said, this is really important, don't screw it up. So we come out, and I am super excited. I'm 23 years old, super excited to meet Stormy. And we get all the gear, and the TV station then, Channel 9, was down on Bannock Street. It's where Channel 12 ended up being. I think it was 12 or 6. Anyway, we go down the basement of the Weather Center. I've got all the gear set up and everything, and I'm like, Stormy's coming. This is going to be great. And Stormy Rotman came into the Weather Center that morning, and he had a scowl on his face, and he came up to me, and he goes, young man, I didn't want this damn thing. The management's forcing me to be here. He thought it was like a gimmick, you know. He was old school. He was a World War II meteorologist. He's not going to have some kid in there showing him some gadget. And so I'm trying to show him all the things, and I'm just way too throwing up on him. So we go to lunch. Cindy's kind of in the back of the Weather Center watching all this, and she's just going, he's way doing this wrong. So we're sitting at lunch at the old Racine's on Bannock Street. And it's Stormy and Bill and the chief engineer and the news director and Cindy and I and Ron, the engineer that worked for our company. And Cindy's sitting right next to Stormy, and she goes, Mr. Rotman, my husband is so excited to meet you. He can't just help himself. And I know he's just throwing too much stuff at you. She goes, I'm a teacher, and I know how to explain things differently. Could you and I just go back to the station ahead of them? And he goes, yeah. And so Cindy says, Mike, why don't you stay here, and Mr. Rotman and I are going to go back to the station. And I'm like, what? You're going to wreck everything. And so they leave, and I pay the bill, and I'm like running down Bannock Street to get back to the station before Cindy screws everything up. And I get in there, and what she had done is she said, Mr. Rotman, I'm not a meteorologist, but I'm a teacher. Can I just show you a couple things on the computer? And he goes, yes. And she says, first of all, do you know how to turn the computer on and off? And he goes, no. So she teaches him that. And then she takes the stylus and she says, let's try making a circle. And this way, a little graphics tablet at that time. And so he makes a circle. And she says, now, it's really important that you have to completely close the circle, because next I'm going to have you fill the circle in with a color. And at that time, if you left one little tiny pixel open, it'd just bleed over the whole screen. And so she showed him the difference, and he makes the next circle, and he closes it, and he goes, oh, well, that's much better. And she said, you could probably, like, circle an area that was under a weather warning. He goes, yeah. And so by the time I get back there into the basement at the old Channel 9, she's got Stormy making circles and arrows, and he's got a big smile on his face, and she broke down the barrier, and he liked it. And so we sold it to Channel 9, and then we told everybody in the country that, well, Stormy Rotman and 9 News like it, and it became the world's #1 weather computer system. So, ladies and gentlemen, a round of applause for my wife. Because without Cindy, Chris Bianchi and I would still be using magic markers and magnets to do our shows. So, all right. What's that, Cindy? It's about teachers, that's right. Teachers change the world. If you want to get in touch with me, you can get in touch with me either at nelsonwx.com or at my Gmail. Today I'm going to talk about science and solutions and a case for the supergrid. Now that's the book. You can either use that address to order a copy online, or easier, grab that QR code. I'll give you all a moment, because that's for free download, and if you have that, you can let all your friends get one of these too. And again, we wrote this book during COVID as a quick reference guide so people can learn the basics about climate change. And after that, if you want to read Michael Mann's book, or if you want to get Catherine Hayhoe's work, there's some really great books that are out there. So did everybody get it? All right, let's go. So people will say to television weather forecasters, you guys can't even forecast the weather tomorrow. How can you possibly know what's going to happen 50 years from now? And it's because climate is easier to predict than weather. Climate is what you expect, and weather is what you get. Climate is a long-term average of conditions. Weather is chaotic, and it changes rapidly. You would expect Miami to be warmer than Denver in February because the climate of Miami would dictate it will be warmer than Denver in February. But you could pick a lousy time to go on vacation, and Miami gets a cold front that stalls, and it's 55 degrees and raining in Miami. And in Boulder, we have sunshine and 60 because we have a Chinook wind. That doesn't mean the climate change. So again, it's easier to predict climate. It's basic thermodynamics. If you add heat to something, it gets warmer. That's why day is warmer than night, and summer is warmer than winter. I use this analogy very often, and feel free to grab it and use it yourself. Weather is like one play in a football game, and climate is the entire history of the National Football League. If it's snowing in Las Vegas or New Orleans or Jerusalem, well, it's wintertime, and we expect more unusual local weather events as the climate system gains more energy, because global warming creates a steroid effect. I took that picture of myself in the mirror just this morning after working out. No. That steroid effect makes droughts more extreme or adds moisture, increasing the rain intensity in a flood event or making a hurricane intensify faster. And the global heat balance is even simpler. It's more straightforward. It's like the basic rules of the game. A touchdown is worth 6 points. A field goal is worth 3. The field is 100 yards long. I see far too often, especially on a certain network, that they bring in so-called experts and skeptics that say, this is really complicated stuff. We can't possibly know all of the subtleties of climate. Well, it's really easy. Heat in versus heat out, okay? If you have less heat going out than you have coming in, it gets warmer. Add heat, gets warmer. It's that simple. And so with the increase in carbon dioxide, which is trapping heat, we are going to see heat waves get hotter. We're going to have more days above 100 degrees. Fact is, according to Climate Central's research, we could see 20 days of 100 or warmer in Denver by 2060. And by the end of the century, 40 days of 100 degrees in Denver, with triple-digit temperatures in Estes Park, the entrance to Rocky Mountain National Park. So the climate of Denver is moving south, and by 2060, without significant emission cuts, eastern Colorado would have the climate of Amarillo, Texas, and by 2100, the climate of northern Mexico. I mean, this is devastating things that will be changing. But it doesn't have to happen that way. A lot of the warming is baked in because, of course, the CO2 stays in the atmosphere for 1,000 years. But with substantial cuts in emissions, we can change that trajectory, and we can keep the planet cooler and more habitable. There have been 5 major extinctions in the geologic history of the Earth, the last one 65 million years ago, but we're in the midst of a 6th. The difference is we are the ones causing it, with all of these issues impacting it due to the burning of fossil fuels. The dinosaurs couldn't stop the asteroid, but we can stop what is happening now. A little perspective. The Earth is 4.6 billion years old. Let's scale that to 46 years. 8 months ago, the dinosaurs lived. Human beings have only been here for 4 hours. The Industrial Revolution began 1 minute ago. And in that minute, we have increased the carbon dioxide in the atmosphere 50%, from 280 parts per million to over 425 ppm. It's the rate of the change. Because people will say, climate's always changed. Yes, but not this fast. And it's too fast for some, if not many, species to adapt. Now, a little homage to the miracle of fossil fuel. Life without fossil fuel was cold, dark, and short. No doubt it has been an amazing thing for mankind. Concentrated energy from the sun, stored in the earth for hundreds of millions of years, essentially the original battery storage. And it's the great energy density that makes it so useful for gasoline and jet fuel and coal for electric power plants. But the rapid increase in demand means we need new energy resources. We need every electron we can produce, but we need them with less carbon. And you see this in the news all the time now. It's not just electric cars, but it is crypto and AI and data centers and high-speed computing. After many years of our appliances becoming more efficient, all of a sudden there's a huge growth in demand that could be 75 to 125 gigawatts in the next 5 years. Now, a gigawatt is the equivalent to a nuclear reactor. We are not going to build 100 nuclear reactors in the next 5 years, but we can build massive amounts of renewable energy and do it quite quickly. Here are some ideas on the solutions. You hear a lot about carbon sequestration. Is that a way to go? Well, let's run the numbers. Scrubbing carbon dioxide from a coal or gas-fired power plant requires that plant to be 30% bigger, so it's not very efficient. The technology to date has not proven scalable. We add 100 million tons of carbon dioxide into the atmosphere every single day globally. If you hit the target of $100 a ton, that's the best we think we can do. Right now, the best we're doing is $1,000 a ton in Iceland, where they can do it with geothermal and because of the soil, because the volcanic soil is very porous. But even if you got to $100 a ton, that's $10 billion. $10 billion a day to remove the daily CO2, not lower it in the atmosphere, just stay even. So if you run that, it would cost $3.65 trillion every single year just to stay even. The upshot is sequestration. It's hard to put the genie back in the bottle. If you look at where we really are, which is at $1,000 a ton, that's $30 trillion a year just to stay even. That's the true cost of burning fossil fuel. You want to talk about an industry we're subsidizing. But we're going to need energy, and quickly, from all sources. So let's take a look at different sources that we have. We're going to need gas turbines, nuclear, hydro and geothermal, and renewable energy. And we need to modernize the grid to provide the power because, again, the huge increase in electric demand from AI and data centers. In order to do this, we have to move fast. We need to be the leader in a new energy economy, or we will lose to China. When people push back on me and say, well, what about China? They're still building coal plants. It's like, yeah, and you know something? They're building massive amounts of ultra-high voltage transmission lines and renewable energy, far ahead of us. So here are some various sources. Geothermal, enhanced geothermal. Turns out that Fervo, which is a 400 megawatt pilot project in Utah, guess who sits on the board? Energy Secretary Chris Wright. Wow, how about that? They use the same techniques for fracking, creating extremely small fissures in the rocks, but these are hot rocks, and they're up to 440 degrees Fahrenheit, and you can use the geothermal at any time to spin generators to make electricity. The Western resources could be up to 90 gigawatts of generating capacity, enough to power 65 million homes. So yes, geothermal, put it on as a source. Great idea. Batteries are increasing in their efficiency and lowering their cost rapidly. Turns out Natron Energy, which makes their batteries with sodium ion, guess who also is a major shareholder in Natron? Energy Secretary Chris Wright. They're manufactured in Michigan, and they're safer and recharge faster. My wife and I were just out here at Terrigen, which is a joint DOD and private-public project with Air Force Edwards Base using lithium-ion batteries. It's a huge facility out there. Now, because it is on Edwards Air Force Base, when you go out there with your drone to take a picture of it, pretty quickly a guy comes out in a Jeep with a .50 caliber machine gun on it and says, "What the hell are you doing out here?" "Well, we're taking pictures of the Terrigen." "Well, get out of here." So, then we were also at this site, Hydrostore. This is a Canadian company. They're doing advanced compressed air energy storage where they'll force air underground and then release it to run a turbine that can run for days. This is a project that has a $1.75 billion Department of Energy grant that hopefully they won't cancel. We'll see. But we're just there at the site. And then Form Energy, using air and iron for their batteries. These are not going to be on a vehicle. Yeah, they're made of iron. They're way heavier than a lithium battery. But it doesn't matter because they sit on the ground. And it uses oxidation, the rust cycle, to charge and discharge the battery. And it can store energy from many hours to many days. There's so much battery research going on. If you haven't looked up a company called CATL, world's largest battery manufacturer, they're Chinese, but they are doing amazing research on things. Battery storage is going to become so incredibly much better, improved in the next 5 to 10 years. And let's talk about nuclear energy and renewables. ACLO, small modular nuclear reactors. And guess who has stock in that company? Energy Secretary Chris Wright on this company as well. Now, we still have some issues with nuclear waste storage, but it combines the fission reactor with a gas turbine to provide power for data centers. And we can replace the gas generators with decarbonized gas in the future. And then, of course, we've all been following nuclear fusion because the old adage is, it's just 25 years away. We're going to have it. 25 years ago, it's just 25 years away. But they're making some breakthroughs. I'm not a nuclear scientist, but I'm reading up on it. They're doing some amazing things, so maybe we'll get there. But how about renewable? Because people say fission is just 25 years away. No, fusion is just 25 years away. No, fusion is just 8 minutes away. The sun. We have a fabulous, dependable, safely located fusion reactor that will run for billions of years. And as we get the battery storage expanding, we'll be able to do this. But the key thing, my friends, is we must improve the transmission system to be able to move that power from where it's made to where it's needed. So that brings us to the supergrid, a high voltage, underground, direct current transmission system. Much more efficient, less line loss because it's direct current and it is DC at high voltage, HVDC. We can use existing right-of-ways for railroads and interstate highways to move the wind resources and the solar resources. Because it would be buried cable, there's much less not in my backyard. Because it's buried, the grid would be protected from solar flares or from the radiation from a nuclear EMP. It would be an investment of at least $1 trillion, but I will show you its return on investment would be 10 to 15 times or more, and I will give you an example. This is something that will make America safer, cleaner, a leader in a new energy economy, and a model for the world. Perhaps that's something that both sides of the aisle could come together, because that's what we do at CCL. We are nonpartisan. We're trying to get friends on both sides. It is the next great American infrastructure project. There are over 2.5 million miles of buried gas and oil pipelines across the United States, but you cannot see them. An underground electric grid would greatly lessen the visual impact, and it would greatly shorten any litigation, because nobody wants to have those big transmission towers across their land. You put it underground, people don't see it. Case in point, my wife and I were just on this 12,000-acre ranch in the Tehachapi Mountains 3 weeks ago. It is a pristine ranch, and it's been there for decades. It's near the town of Stallion Springs. And there's a transmission line that goes across it. We were out there with the owner of the ranch, and he said, yeah, that's always been there. And then we're out on ATVs riding around, and I see this sign that says gas pipeline. And I'm looking, and I said to the owner of the ranch, I said, Lubor, where is this gas pipeline? He says, oh, they buried that back in the 60s across the ranch before I bought the ranch. So I'm looking a little bit closer. Can you see it? Let me help you. It's right there. But you know what? You had to really look because it's buried. Out of sight, out of mind. An underground electric transmission grid would be the same thing, safer and with much less visual impact. So what does it look like? Well, the cable would look something like this. You can see the conductor is solid copper. It's about the size of an orange. And then you have the various sheathing and insulation around it. You can bury this 6 feet underground, or you can put it underwater. The national security advantages include a massive solar flare would be catastrophic. If you've ever searched the Carrington event, that was a solar flare in 1859. We had telegraph wires at the time, but not much else out there. But the telegraph wires had electricity induced in them by the solar flare, and the telegraph offices caught fire. Imagine a similar event today, what it would do with our highly connected society. Our electricity wouldn't be off for a day or a week. It'd be off for months, if not years, as we would burn out all kinds of above-ground insulators and various wires and transformers. An EMP, if North Korea decided to light one up over Kansas, would do the same thing. There have been some books written about that. Well, our lifestyle would go back 150 years, but very few of us know how to live as we did 150 years ago. We're not really good at hunting our own food anymore. All commerce would shut down, banking, healthcare, food supply threatened. A shielded underground transmission grid would protect us from the worst effects. National security, along with eventually decarbonizing our grid. Maybe both sides of the aisle could come to an agreement on that. There have been two great American infrastructure projects. Abraham Lincoln, a Republican, signed the Transcontinental Railroad Act in 1862. It didn't bankrupt our country, it transformed our country. And in 1956, Dwight Eisenhower, a Republican, signed the Interstate Highway Act, also transforming our country. The next great American infrastructure project should be the high-voltage, direct current, underground supergrid, connecting energy sources to users all across America. This is an important project that we could use the railroad right-of-ways. Railroads are losing their main source of revenue, which is hauling coal. Using their right-of-ways will generate a new source of revenue, saving the railroads, and the railroads would also be able to use that infrastructure to take their locomotives off diesel and make them electric. Much of the European railroad system is electrified. We could do it here in the United States. And it would help middle and rural America. Gee, how do those states tend to vote? Pretty red for the most part. Well, farmers and ranchers wouldn't be mandated to grow electricity. They could choose to grow electricity, and it's a pretty valuable crop. And we would be dominant as the world's greatest producer of all forms of energy. So let me show you the value of utility-scale solar. This is what it looks like out in California in the Antelope Valley near Edwards Air Force Base. It is a sea of solar panels and wind turbines. And in full disclosure, my wife Cindy and I do land investing work out there, putting investors just ahead of these utility-scale solar farms. If you have any interest in learning more about that, Cindy's here and I'm here. We can chat later. But let me show you what's going on and why this is changing so quickly. The cost of utility-scale solar in 2009 was about $350 per megawatt hour. It has now dropped to $60 per megawatt hour, far cheaper than coal or nuclear. I'm a supporter of nuclear, but it's really expensive and it takes a long time. We can put in a gigawatt of solar energy in about 8 months. So I did some numbers, And I won't run you through all the math, I'll do it for you. At $60 per megawatt hour, that's $1,440 for 24 hours, or about $500,000 for a year. According to NREL, it takes about 5 acres of solar panels and batteries and inverters and fencing and access roads per megawatt of solar energy. So that means, since it's not sunny all day long, you have 8 hours of sun and 4 hours of battery storage, the value of solar energy ends up being $50,000 per acre per year. Keep that number in mind. So I thought, what else can you grow on an acre of land that would be that valuable? So I went to ChatGPT and DeepSeek and burned up a whole lot of electricity to do it and asked for the averages. And I got $700 an acre for soybeans, $1,000 an acre for corn, alfalfa hay, $2,000 per acre. If you had trees, once in a generation, you could harvest your oak or walnut. Pistachios, $5,000, almonds, $6,000, and oranges, $10,000. So I said, Cindy, this isn't even close. Is there something else? And she said, try saffron, because saffron's the most expensive spice in the world. So I said to ChatGPT and DeepSeek, what's saffron worth per acre? $30,000. So the upshot is solar farming can be very profitable. And did you know that alfalfa uses most of the water of the Colorado River? It's used to irrigate alfalfa fields in Arizona and California. It's the biggest water user in the Southwest. Solar farming, you wash the panels once a month. So let me show you the impact of infrastructure. This is an example in California. We're going to go up to the Antelope Valley, north of Los Angeles. This is what the Antelope Valley looked like in 2008. You see where Edwards Air Force Base is and where Lancaster is. And out farther to the west, that was all agricultural land, mostly almond and pistachio groves, but failing because of climate change. Not enough water, getting too hot. So California passed some laws back in 2006, starting with Arnold Schwarzenegger, another Republican, to decarbonize their economy. And the result of the laws were they built the Tehachapi transmission line and they built the Barron Ridge transmission line. 2 very expensive projects that cost $3.6 billion. Electricity is not cheap in California, a lot of it because of insurance losses from wildfires. But this went in, California Edison and Pacific Gas and Electric. The old adage from Field of Dreams, if you build it, they will come. We suddenly had transmission lines that could bring electricity down to LA. So within that orange rectangle, here's what happened. That all turned into solar fields. $60 billion. A $3.6 billion investment resulted in $60 billion of First Solar, which is Warren Buffett, Google, EDF Renewables, Amazon, Duke Energy, Masdar, which is Arabic for source. Masdar is the United Arab Emirates. Imagine a petrostate doing solar energy. So let's go up to one of those solar fields, Big Bow Solar, which is right in between the 2 transmission lines. It's owned jointly by EDF and Masdar. That's what it looks like. It's the first solar energy field that also had battery storage. And this is what it looked like. This is an assessor's parcel map. Every one of those rectangles of land was owned by somebody. This is old farmland. If there had been a mine on it, they dug that stuff out 100 years ago. If there was oil there, it's long gone. So this was mostly just fallow, failed farmland. All subdivided and owned, that's what it looks like. It had little value prior to the development of low-cost solar energy. Every one of those parcels had to be acquired one at a time, and they would say, Luke, we understand you own 10 acres of land out here. We'd like to buy your land to put in a solar field. And the negotiation would begin. So this is Luke right here, all right? He was very savvy. And he bought that 10-acre parcel of land as an investment back in 2013 because he saw those power lines and he knew what was coming. And he's an environmentalist. And he paid $20,000 for it, and he sold that to EDF and Masdar in 2020 for $16,000 an acre or a 700% return on investment. Made you a happy man, didn't it? Yeah, you need that. By the way, if you know of the rule of 72, using a 4% return on your investment, that would take you 50 years. And this investor did it in 7 because of the transmission. So brownfields are previously developed land areas. They're old landfills, they're old closed industrial sites, abandoned mining projects, farmland that's no longer useful. There are over 450,000 of these sites in the United States. They're a local eyesore, and they're often very expensive to clean up or remove. Turning these sites into solar fields is an excellent solution, making the land productive. Even a small number of these sites, turning them into solar farms, would generate a lot of electricity. We can transform blighted areas into valuable resources. Turn brownfields to bright fields. Estimates are there are 5 million acres of brownfield in the United States. Just 1 million acres would produce 200 gigawatts of power per year. 1 million acres of brownfield land could produce $50 billion a year in electricity. If we built the transmission system to move the electricity from source to need, we could utilize these marginal lands. Transmission lines can make this marginal land valuable and productive. My friends, we can solve our growing power needs and generate a great deal of wealth. In 1960, when John F. Kennedy accepted the nomination for president, he said, "We stand today on the edge of a new frontier, a frontier of unknown opportunities and perils. It would be easier to shrink back from that new frontier, but the times demand new invention, innovation, imagination, and decision. Our problems are man-made, therefore they can be solved by man. No problem of human destiny is beyond human beings." We got to the moon in less than a decade. My friends, with the proper political leadership, even in this very fractious time, we can still do this. So that is my case for the supergrid. If you have questions, you can contact me. You can contact my dear friend Sandy McDonald, who's the author of a book called Transformation, all about the supergrid. And Chip Cummins is the head of the American Renewable Energy Institute. And we are all working together to try and get this in front of our political leaders. There's some other areas that I used for sources: Intersolar and Energy Storage North America and RMI.org. Please feel free to take a picture of these and contact them. What I'd like to do, Luke, is have a seat and take some questions.
Yeah, thank you, Mike. First, can we have a round of applause for that great presentation? I find that. And just raise your hand and I can bring you this microphone. And here we go, Bonnie.
Hi. I just saw a program about the enhanced geothermal, and about using the fracking technology for that. And my question is, do they still have to use the chemicals in the fracking technology to pull the
various fracking chemicals? Probably. Good question. And I would think that they would still need to have those little particles and stuff that they can kind of get there to pop everything. I don't know enough about that part of the technology. Worth checking in, though. I will make I'll do some research on that. Maybe somebody knows?
I can answer some of that. Yeah, good question. My name's Nathan. I worked at the EPA. I worked at the EPA for a number of years, and in fact, I was on the hydraulic fracturing study that EPA did. And so I learned a little bit about hydraulic fracturing. And you asked the question of whether they basically need to keep open those tiny little fissures that Mike talked about. And if they're going to use that for geothermal, I would think the answer has to be yes, they need to keep open those fissures, which would mean that yes, they do need to crack open the rock when they fracture it. and that would mean that they are going to continue to use the formulations of the chemical formulations that they've developed for oil and gas exploration and other uses of hydraulic fracturing. And the whole point of those things is, in addition to creating those fractures, it's to carry what is called proppant, which is basically sand, into the rock to keep open the fractures after they release the pressure, and the cracks would otherwise just close back up again. They prop them open with the sand. So they need to be able to carry that sand out on those long fractures, and so they would probably end up using the same formulations that they already have.
And I assume that's not the best thing, but what did you find as far as your research into so much of that's proprietary and the oil companies won't really tell you what's going on? Do you have any more information on that? We'll finish this thought.
Yeah, I'm sorry, just to finish that. Yeah, it's what a lot of oil and gas companies now use is called slick water. And the slick water is just water, mostly water, like 99-point-something% water, and some sort of like glycol or other organic chemical that's added in that makes the water slippery. In other words, it reduces
surfactant.
Yeah, surfactant. It reduces the friction that you would otherwise need to increase all that horsepower to create all that pressure to push that fracture out into the ground. So there are chemicals. Yeah. I'm not an expert on which chemicals they are. As you said, Mike, they keep that pretty close to the vest.
Yeah. You know, the thing is, there's no free ride on any form of energy. I mean, even when you talk about, you got to recycle the solar panels or use the rare earths or whatever, but I think the more responsible that we can become and the smarter that we can become and the more efficient we can become, that's really the best solution on all sides of the aisle. Efficiency shouldn't be a partisan issue. That should be a good thing, just not Doge.
Okay, couple more questions.
Mike, you very graciously did a little video for the All Careers Initiative a few years ago where we had a watch party about a video that says that all careers of the future need to be greener, otherwise we won't have a green economy. We can't have a green economy with 50% green and 50% not. So thank you for that. And I've been doing energy education for the last 35 years myself. And a lot of what you brought here is just great and fascinating. It's going to have to be part of the solutions that we go towards. There's one thing I'm concerned about, and that is back in the 80s, there was this cold fusion promise. It was in Newsweek or Time magazine, and people were very excited for a while. Then it died out. It was not possible, or it was at least not at that time. But a lot of folks started talking at that time that wouldn't necessarily be the answer to sustainable life on our planet, because what do you do with energy is a big part of this. We convert land into other uses, and we mine, and we do all sorts of things. So I wonder if you could speak a little bit to that part. You know, how much energy are we going to be able to use without transforming life into concrete and steel and, you know, all the other chemicals and things like that?
I remember that we were so excited about that. It was like, you know, fusion in a bottle, or Mr. Fusion from Back to the Future. But I'm still hopeful it will figure that out, but I think that when the Atomic Energy Commission in the 50s and 60s talked about the peaceful use of the atom and how we could transform our world with that. And I don't think we've been particularly effective at that. I hope that we have the moral part of the equation moving forward, so that with all of our discoveries, we don't just make the wrong choices and we're not here. Because there have been 5 other extinctions. When people talk to me about, you know, the climate's always changed, I'll say, yeah, just ask any dinosaur that you see when you meet them on the street. because if the changes happen too fast, we may not be here either. And I oftentimes in my climate talk reference the pale blue dot and Carl Sagan's magnificent words about how this is our only hope. That's it, right here, that little pale blue dot. That's where everything that ever was occurred. And at least for now, it's our only place. There is no planet B. And I think that's where we need to have wise leadership, spiritual leadership. I so appreciate the work of the mission of the Jesuits in terms of caring for creation. I don't know if I've said anything to add to that, but somebody over here in the center of the row has a comment, I think. But thank you for those nice words.
In a minute, but this gentleman's been waiting to ask a question.
Martin Walker, Colorado Renewable Energy Society. Many of the projects you proposed here have enormous price tags, and so I think the key to solving these problems will be in getting financing. And I was wondering if you had any thoughts on those. I mean, the value proposition is fantastic, but the financial community is really fickle. I mean, the climate tech was all the rage, or clean tech for a while, and then everybody shifts to AI, and huge pots of money in theory available, but not being allocated for these kinds of projects.
Well, all the railroads in this country are owned by billionaires, and this would be a huge source of revenue for construction companies, manufacturing companies for the cable, et cetera. So it could be a gigantic boost for the economy. And I think what it really requires is our billionaire class to understand that they can transform the world for good or for evil. If you had enough money that you could give away $1 million a day to good causes, it would take you 300 years to give away $1 trillion. Yeah, right. Well, after Luke made all that money on that land, but so 300 years to give away $1 trillion. The 3 richest men in the world are worth well over $1 trillion combined. So it would take them 300 years to give away $1 trillion. It would take them 100 years to give away $100 million a day. And they could give away $10 million a day. They could give away $100 million a day from now until they die, every one of them, $100 million a day, and they could still afford their yachts, their jets, and their multiple homes in the most expensive neighborhoods in the world. $100 million a day for good in this country. Not saying that they will, just saying that they could. And so when we are firing park rangers as a means of somehow saving our economy, it's just stupid.
Thank you.
Hello, Mike. Ken Orgoglioso from the Northern Colorado Citizens Climate Lobby. I noted in the earlier part of your presentation where you had a slide on transitioning from coal to other sources of energy, that one of your slides depicted gas turbines, and that possibly in the future going to carbonless energy source, which I assume would be hydrogen. And I was wondering if you had any information you could share on how viable a solution that would be, transforming a gas turbine to hydrogen, which I know is a much more energy-dense fuel.
Well, what we've been talking about, and Dr. McDonald, whose contact information up there, has done a lot of work on this. He was the head of NOAA, and he ran the Forecast Systems Lab up in Boulder for many years. I've known him for 30 years. Sandy's one of those truly brilliant people, so feel free to reach out to him and say you were here at this today. And we can decarbonize the gas. And so the gas turbines are incredibly efficient, and they start up fast. So you can have wind, solar, battery, and then gas turbine backup. Now, we're not going to decarbonize that gas certainly during this administration. But if we can begin to build the supergrid project, it won't work without the infrastructure. The project has to come first. And then, when we get into a different regime, can look at taking that methane and replacing it with decarbonized gas, which we can do with green hydrogen. We can make that transition. This is a project that we'd like to start now and really have it completely up and decarbonized by 2050. And we can do it, but it's going to take some leadership, and it's going to take making it a national priority. You know, we made gearing up to win World War II a national priority. We did it in 5 years. We made going to the moon a national priority. We did it in 10. We could do this project in the next 25 years if we can get both sides of the aisle to realize there are benefits to everyone. And that's what I applaud Citizens Climate Lobby, that you do speak to both sides. And this could be a huge project, especially for the Midwest, where the farmers and ranchers could take that 10 acres of land that's not very fertile, and if they had the infrastructure, they could decide, I'm not being mandated to do this, but I'm going to put solar on that 10 acres. Because at $50,000 per acre per year, I can save my farm by having that 10 acres be solar panels.
Okay, Phil has something.
Yeah, getting back to the big money and citizens' climate change, which doesn't usually talk about big money. Well, we used to, actually. So the fundamental tenet was that we should get a carbon price, a tax on carbon. We usually called it a fee, and then all that fee monies would be then given back to the taxpayer as a dividend, a monthly check, and that we never succeeded. We would still like to succeed. Do you see any way forward to re-implementing a push for a carbon price, maybe combined with the other things you're talking about, possibly to do some of the funding for this envisioned transformation of energy?
Short answer, if we called it a carbon tariff.
That's a real thing.
Actually, what it would be is, you saw how inexpensive wind and solar are, down around $60 per megawatt hour. We would do this with a 3 cents per kilowatt hour electric fee. But the difference is, because you would have so much cheaper energy, because you would open up all of these to be available. So it would be simply the cheapest form of energy is going to win, that you'd actually come out with far less expensive electric costs, because coal and nuclear are so very expensive. So building this project, which would be a $1 or $2 trillion national project, would result in cheaper energy costs for the American consumer, by far.
Okay, Rob has something.
Mike, a question about the supergrid. Can you build those transmission lines one at a time, or do you have to have the entire grid? The reason I ask is Xcel is planning this monstrous transmission line out in the Eastern Plains. Could that be a start for the supergrid?
Absolutely. To build it underground is about 3 times more expensive in construction, but far cheaper in litigation, because to get that one big power line that Anschutz was part of, it took them 20 years to get that all through the courts, because every time you made one change, there's a brand new lawsuit. Doing it underground using the existing rail right-of-ways, we only need about 10 feet of right-of-way off the track, and you bury it in a trench about 6 feet deep. And so it ends up being far cheaper to put it underground, again, because the example I showed you, if all of those 2.5 million miles of oil and gas pipelines were 6 feet above the ground, people would have a fit, because they're ugly. But the next time you drive up north on I-25, take a look. There's buried gas pipeline the whole way, and every once in a while there's a little above ground spot where they have a little station where you can have the valves, etc. It's all buried. And the example I showed you on that pristine California ranch, you don't even see it unless it's pointed out. There is a project, if you want to look it up, it's called the SOO, S-O-O, Green Line. It's a high voltage underground transmission project that brings wind energy from Iowa into the Chicago area. We don't have to build this all at once, but we could start in phases and develop it. There's not nearly enough transmission in the Midwest, from the Dakotas to Texas, to handle all the wind reserves that we have there, and solar. Tremendous opportunities for those resources, but we don't have the transmission to get it there. That farmland in California that was worthless became valuable because once they put the infrastructure in, the solar companies realized we can make a profit by putting solar panels in here. You can't build the panels first. You've got to have the transmission at least in planning and beginning of construction before those companies will come in, because just the battery storage alone, and these are big containers, they look like the back of a semi-truck, they're all filled with these little lithium-ion batteries, thousands and thousands of them. That's a $75 to $100 million project to put in a battery storage facility that might cover about 10 acres. So they're not going to put that in until they know they can plug it in. Interstate?
Would you have put that, and now you can do a $1 or $2 trillion, I can yell, I'm a teacher.
Believe me, I hear everything she says.
Oh, okay, so how much was it to put in the railroad? At that time, would it be the equivalent of what it would have put in now? I mean, like, are we talking about it being exponentially more expensive to do
the
this?
The equivalent 1 to 2% of GDP. In the
Is that about the
1860s,
same?
in the 1950s, and in the 2020s, yeah.
Okay, because I think that's an important thing to continually bring up.
Yep.
Okay.
I mean, even the Apollo project was $1 trillion back in the 60s to get us to the moon. And questionable in some cases about what was the real value, what was the meaning of Apollo. And we got Velcro, and we got Tang, and we got to the moon, and we're high-speed computing, all of those things. But ultimately, Apollo was a Cold War effort, because to get to the moon, you needed rockets, big, powerful, dependable rockets. Those same rockets could be used for nuclear war. And so Apollo was primarily a race to win the minds of the world for our side and not the Russians.
Mike, back on the supergrid and the buried pipelines, I guess my question is, what are the pitfalls of a buried pipeline, a buried grid, thinking about the thousands and thousands of miles of buried gas and crude oil pipelines, et cetera? I was thinking groundwater, even earth movement, such as anything like that that you can, what have they had to encounter and deal with, and how has that gone?
There's always a trade-off, and you'd have to be very careful and responsible about where you site it, but those railroad areas already have been used for 150 years, and they're kind of, in a way, their own little brownfields, if you will. I mean, they've all that traffic going through, first with coal-fired locomotives and then diesel. And so I don't think there's a huge downside on that using the railroad right-of-ways. Now, there is also a company called the Ray, R-A-Y, theray.org, I believe it is. And that is a highway project, a pilot project in Georgia, where they have already done all of this. They've buried all of the underground transmission. They have solar in the turnoffs, on the clover leaves and stuff. It's a project down there. And that's worth looking at, because they've already mitigated a lot of that with computer models so that you can exactly see what you need to avoid hitting using their computer model. And we could do this on a larger scale. So look up, I believe it's the ray.org, try.com, try.net, but it's about a highway down in Georgia. And the woman that you'd want to talk to is a friend of mine named Allie Kelly. And she's the public relations person for the Ray.
Okay, I'd like to make, I have one more question and then move out into the lobby and sell some of those books.
Okay.
And you've been very generous with your time. Thank
Sure.
you.
Yeah, love talking about this stuff.
My ears perked up when you said copper cable, and I'm hearing all the time about how we're running out of copper, it's becoming too expensive. If you could address that.
I wish I'd have brought it. Cindy, I've got to just put it in the bag, that new little transmission cable that we got. There is a company called TS Conductors out of California, and they have developed a new transmission cable that has a carbon fiber core, and then it's wrapped with annealed aluminum. Let me explain. Most transmission cable has to have the conductor be strong enough to carry some of the weight of the cable. And this is mostly for above ground cabling, but you hear a lot about reconductoring transmission lines where you can make the existing transmission line more efficient. This new type of cable has a carbon fiber core, which is far lighter and stronger than a metal, a steel core. The aluminum is the conductor, not copper in this case. And if you anneal aluminum, what you do is you heat it up and you cool it. You heat it up and you cool it, and it changes the molecular structure of the aluminum, making the electricity pass through it much more efficiently. So you get less line loss, you get less heat. And so you can put a lot more energy, about 3 times the amount of energy through this cable. But annealing aluminum weakens it, so you can't have the aluminum responsible for any of the strength required in the cable. But since carbon fiber is much lighter and 5 times stronger, that has solved that problem. So this is a breakthrough in transmission cabling that heretofore the transmission cables were essentially the same for 100 years. And so this is a new technology coming in. Imagine we can invent our way out of many of these questions. And using it this way will, in fact, make these cables much more efficient and economical. So, but I have this beautiful piece of this transmission cable. What's that? If I didn't put it in the bag. That's what I meant. Got to remember to put it in the bag. It's sitting at home in the basement. It was next time. All right. So, answer to that. There are technologies coming up that will alleviate some of that concern. It'll be an expensive project, but it'll be a project that will change our nation and keep us competitive. Because I'll tell you right now, China, the largest solar field in the United States being built right now, it's called Belfield Solar. It's right north of Edwards Air Force Base. It's 8,300 acres. In China, they have 2 solar fields already online that are 3 times that size. All of Western China is filled with solar and wind resources, and they are building at a rapid rate ultra-high voltage transmission to bring that to all of the major cities because they are transforming that country. Look up CATL, which is the battery manufacturer, and BYD, which is the largest car maker in the world, bigger than Tesla. They are in China, so you can't buy them here, but the buses on the 16th Street Mall in Denver are made by BYD in Lancaster, California. We've been to the factory. We were just there a couple weeks ago. And if the American auto manufacturers continue down this road of building internal combustion cars, most of them will not be in business by 2035 because battery-powered cars are going to be everything. 120 years ago, most people didn't own automobiles. Only rich people did, until Henry Ford invented the Model T, and anyone, for the most part, could buy a car. When, by 2030, battery-powered cars are not only better, but cheaper than internal combustion cars, everyone will buy electric cars. I haven't run into one person yet that said, you know, I tried it, and it was just too quiet, and it was too fast, and I missed going to the gas station and spilling gasoline on my shoes. I decided to just go back to an internal combustion car. No, everybody I talk to loves them. My daughter took a guitar wire and pulled the T off of her Tesla. But she loves the car.
Thank you. Well, let's give applause again to Mike, and thank you for, meet us out front for the book signing.
Yeah, we'll see you out front.